Dear experts, I'm Yikang from China Construction 6 Engineering Bureau. It's such a pleasure to share our research today. My topic is an intelligent platform for lifting device selecting and analysis on construction engineering. First, I will start with a quick introduction to our company, introduce the research background, and then show that how we build the platform and validate the results. Finally, conclude with key contributions. Before delving into the technical solution, allow me to briefly contextualize our company. China Construction 6 Engineering Bureau was founded in 1953. We are a Korean subsidiary of CSCEC, the world's largest investment and construction group. We have got solid resources, including $658 million in registered capital, total assets over $9.86 billion, and a team of more than 20,000 employees. In 2023 alone, we landed new contracts worth more than $30 billion. When it comes to qualifications, we hold 3 special grade general contractor certifications in building construction, municipal utilities, and highway engineering, and multiple grade A specialized qualifications. In technological innovation aspects, we have achieved 2 National Science and Technology Progress Awards, 20 Luban Awards, which is China's top construction honor, 5 Jintinyu Awards, and over 20,000 national patents. Internationally, we operate across more than 30 countries and regions, especially in the Belt and Road nations, such as the Brunei-Tempurung Bridge, the Israel-Tel Aviv Light Rail Green Line, and the Dubai Digital Park. Now, let's talk about why we needed this platform. The construction industry is changing fast. On one hand, innovation drives technological development. Intelligent construction is now a global must-have powered by IoT, big data, cloud computing, and AI. On the other hand, policies support technological development in China. The 14th Five-Year Plan explicitly mandates the development of intelligent construction, and CSCEC also launched its 136 digitalization project to promote enterprise-wide digital transformation. These policies and technology drivers highlight the need for innovative solutions in construction. Under this background, it is necessary for the construction industry to undergo intelligent transformation. Since lifting equipment is a crucial piece of machinery on construction sites, its intelligent selection and computational analysis has become a key issue of concern. Now let's focus on the core part, how we built the platform. This section will cover its overall framework, system architecture, front-end interface, back-end interface, and database design. As we know, lifting equipments, including tower cranes, truck cranes, and crawler cranes, and so on, are vital for construction. Picking the right one and checking its foundation stability directly impacts project safety and efficiency. But here's the problem. Traditional methods rely on manual calculations or basic software. They are slow, error-prone, and cannot keep up with the demand for precise, low-cost, efficient workflows. Even commercial tools have gaps. Their functions are incomplete, and they are hard to customize. Moreover, equipment data is all over the place from different manufacturers, so finding the right specs usually takes a long time. Therefore, we developed this platform. First is framework. We use a low coupling, high scalability industrial internet structure. That means it's stable even when many people use it at once and easy to expand later. Security is a top priority that is deployed on our company's internal multi-threaded server, and only authorized staff can access it via VPN. And we also have a 4-tier permission system. Only the headquarters can oversee everything. Every user action is logged, which helps with monitoring and troubleshooting. We adopted a technology stack that incorporates front-end web development techniques, the Flask backend framework, and object relational mapping database methodology. The front-end employs Vue 2 framework integrated with Element UI components, tasking with the presentation of basic interface information and facilitation of user interaction. The backend is powered by Flask, a lightweight yet powerful Python framework that enables seamless data exchange and interaction between the front-end interface and the database. And this stack ensures seamless collaborations. The front-end users input requests and backend processes them, interacts with the database, and returns results, thereby creating a smooth workflow. The front-end interface has a new project interface where users can create, save, and modify project information. Each project gets a unique ID for easy retrieval. The system is bifurcated into two specialized modules. First, the fixed lifting equipment module addresses tower cranes. It has two functions, intelligent selection and foundation calculation. For selection, users can retrieve detailed specifications from a database of manufacturers. For foundation analysis, it supports 12 subtypes across 4 categories, including rectangular, cross-beam, cross-shaped, steel beam, and steel platform foundations. And second, the mobile lifting equipment module addresses truck and crawler cranes. Its calculation module automates or trigger reaction force analysis for truck cranes and foundation bearing capacity assessment for crawler cranes. For this calculation procedure, users can generate detailed calculation sheets into formats, an editable doc file for further customization, and a watermarked PDF official submission. This dual output feature ensures both flexibility and document control. The backend module integrates many automatic computing programs, following the requirements defined by Chinese standards. For tower crane foundations, the computational sequence begins with the upper bearing platform analysis, which could be a rectangular pier, cross-beam pier, cross-steel beam pier, or steel structure pier. And second, the intermediate support frame is evaluated, accommodating both lattice columns and steel concrete composite columns. Third, the lower bearing platform, typically a rectangular slab. And finally, the pile foundation is designed. It analyzes loads, stresses, soil capacity, and stability in seconds. Then outputs details like component sizes and reinforcement amounts. For mobile equipment, the backend implements two distinct modules: the truck crane outrigger reaction program and the crawler crane assessment module. The database schema concludes four components. The conceptual layer outlines logical structure, including manufacturers, crane types, parameters, users, and their relationships. The internal layer details physical storage, and the external layer offers user-friendly and security views to restrict sensitive data access. And the mapping layer connects these levels. It converts the logical model to physical storage and their views, keeping data efficient and secure. After developing the platform, we conducted rigorous validation. Since all the calculation algorithms and processes strictly comply with Chinese technical specifications, their results are consistent with traditional manual methods. We conducted semi-structured interviews with technical managers from 6 real engineering projects and compared work efficiency by using the platform and traditional methods. Results show that comparing with traditional manual methods, using the platform reduced over 90% time cost in lifting equipment selection and analysis. And finally, the conclusions. This platform integrates front-end, back-end, and database technology to unify lifting equipment, information management, and automate calculations. It solves the problems caused by repeated work and fragmented data, making equipment selection and calculation more standardized, faster, and error-free. And it can effectively improve working efficiency, accuracy, and project management capabilities. Okay, that's all. Thank you for your attention.